I have it for absent students. Okay. Guys, when you punch these into your calculator, which you should all know how to do, this one you get what? Undefined, right? So it's -1 comma what? Nothing, right? So there's no point, right? In fact, there's no points for any negative x values, are there? No. What's the square root of 0? 0. So when x is 0, y turned out to be 0, didn't it? So there's 1 point on the graph right there, 0 comma 0. What's the square root of 1? So when x is 1, y is 1. Plot that point. What did you get on your calculator when you punched that in? About what? 1.41?
2.
Okay. About
1.42.
no, 414 rounds down. Okay. So 2 comma 1.41 would be right about here. What happened when you put in a 3? What's the square root of 3 on your calculator? 1.71?
7.3.
Is it 7.3?
7.3.
All right, 7.3.
Yeah.
Okay, so that would be right about here, wouldn't it?
Yeah, about there.
And then what happened when you put in a 4? What'd you get? 2. So when x is 4, y is 2. Guys, please. Shh. Jack, pay attention up here. What happens you put in a 5? What do you get? 2 point what? Come on, guys. 2 point what? 2 what? Okay. So when x is 5, y turned out to be 2.24. Okay, so you got the point 5 comma 2.24. Now you guys, these are just some points on the graph. Obviously there's an infinite number of points. And so if you connect the points that you found with a smooth curve, what you're going to see is it goes like this. And it'll go on and on like that. So again, it's a smooth curve that what? Rises gradually from what? From what? Left to right. Yes? Do you agree that's what it looks like? Why? Now what's the domain, Brett? Well, the domain is all the x values, right? So looking at it, Brett. Yeah, but you don't list them. Aren't there other points in between that we just didn't find? And so the domain is all x's that are what? No. There's no negative x values. We just said it's undefined. All x values what? Very good. Okay. Jack D, what's the range here? Jack D. So how would you say that? Y is greater than or equal to what? 0. Do you agree that the lowest y value you see right here is 0 and then it goes up? Do you agree this goes up and to the right forever, doesn't it?
Yeah.
And that's why you start at a y value of 0 and go up. You start at an x value of 0 and go right. So everybody with me on that? Okay, problem 2. You guys, this is the basic or parent function. And we all know that this is a what? It's a graph that what? Starts at what? 0, 0, and then what? Rises gradually from left to right, just like we saw in the activity number 1. Now, ready, Adi? Can you put all that stuff away? Just clear your desk. Okay. So, what's different about this and the basic function? What's different? You got a -2 where? Inside. In the past, what did that do to the original graph? It moved everything 2 units to the what? To the right. So that would be my prediction, right? That the graph will shift or move 2 units to the right. And let's see if we're right on that. Are you ready? Okay, heads up, guys. Here we go. Watch. I'm telling you, you guys are going to lose points if you're doing anything but focusing here. Okay, so what do you think, guys? When I hit Zoom Z standard to graph like I always do, what does the graph look like? It starts now at what? Does it look like the graph got moved 2 units to the right? Yes or no? Yes. So now it starts at 2, 0 and goes gradually up and to the right. Yes? Okay. Problem B. Now what are we doing? What's different now? What's different now? We're subtracting to where? Outside the function. So, according to what we learned in the past, what should that do to the graph, guys? It should move everything what? 2 units. Hello? No. Don't guess. Which one is it? Down. Thank you. So, based on past experience, this graph should be shifted 2 units down. And let's check to see if we are right. Ready? By the way, how do I get out of the square root? Because if I just keep typing, it'll stay inside the square root. Hit the right arrow button, and that'll take me outside the square root. Right? Another check. Okay? So, when I hit Zoom Z standard here, sure enough, the graph moved down, didn't it, Brendan? Heads up. Okay, so we were right. All right, so you should be able to make these predictions and then check your predictions by graphing on the calculator, so you don't have to make a table every time. Is that clear? Okay, now, with me, Trevor? Yeah, you okay? All right, so this is only one of several things that we're doing today. Again, we've got a lot to do, so let me get the notes out to you and we'll get started. Again, you're going to need to take good notes so that you can look at these tonight when you're doing a whole bunch of different homework problems. We're actually doing 2 sections today, as you can see. Take a look when you get the packet. I only give you what I feel you need, so. What? Pass this back. Pass those back. Okay, ready, guys? Okay. Ready? Okay, Drew, can you read number 1?
You should now memorize the graph y x squared looks like.
Okay, go ahead. What does it look like? What does it look like? Read. Keep going, Drew. Mike, every time you turn around, it's -1. You should only be facing the front. Go ahead, Drew. It starts at?
The point 0, then rises gradually from left to right.
Okay, isn't that what we saw in the activity?
Yeah.
Okay, so from now on, I want you to memorize that's what the graph looks like. It starts at the point 0 and then rises gradually. It is not a what? It's not a line, but more like a piece of a parabola. It curves gradually. Is that clear? So don't draw a line. It is not a linear graph. You should know that. Okay. And also, we saw this in the activity, what the domain and range are. Now, what we're going to do from here is this. Jessica, can you read it?
You should also know its domain and range based
No, right here.
You should also then be able to roughly sketch the graph of equations, which are translations/transformations of this basic memorized function graph. Then use the new graph to give the new domain.
Okay, so that's what we're doing here in example 1. Okay. Everybody agree that in this equation, you got a minus 3 inside the function, which we already said should shift everything 3 to the what? Right. So normally the graph would start at 0, 0, but now it's going to start where? At 3, 0. Do you agree that the point that would have been at 0, 0 is now going to move 3 to the right to there? That's going to be the new starting point, isn't it? Isn't that going to be the new starting point?
Yeah.
Why don't you have your pencil in your hand, and why aren't you writing this down? That,
The circle?
this. There it is.
Just wrote that.
Okay, good. All right, everybody agree that's what it looks like? Yes? Right? So it starts at 3, 0, and it rises gradually from left to right and keeps going. That's why I put the arrow. Okay, so based on that graph now, Jack G, what's the domain? Quick.
X is greater than or equal to 3.
Okay, good. Steve, what's the range?
Y is greater than or equal to 0.
Okay, good. All right, let's look at B now. What's going on here? Well, I've got an addition of 1 inside the function, which means everything should what? Move or shift 1 unit to the what? Left. So the point that would normally start at 0, 0 gets moved to here. Everybody agree that's a new starting point for my graph? Yes? And then again, from there it just rises gradually from left to right, like that. Okay, so based on that graph, Jack, go ahead. Jack in the middle, in the back, go ahead. What's the domain?
Oh, X is greater than or equal to -1.
Okay, good. Leah, what's the range?
Y is greater than or equal to 0.
Okay, good. All right, Joanne, let's look at C. This time I got a +2 outside the function, right? And so doesn't that move everything 2 units up? So what would have started at 0, 0 now gets shifted where?
0, 2.
Yep, to 0, 2. Everybody agree that 0, 2 is my new starting point for the graph? And then from there again, it looks like it normally would, which is just rising gradually from left to right. So based on my rough sketch, so on the homework tonight when I say graph using a rough sketch, this is exactly what I want you to do. So if you're not sure what to do on those homework problems, look at these examples, because we're going to have a ton of different examples today. By the end of the hour, we're going to be doing something totally different than this. Okay? All right, quickly, Mike P., what's the domain? Greater than or equal to what? Can't hear. 0. Okay. What is the range, Nicolette?
Y is greater than 2.
Okay, good. All right. Now, let's look at D. Is there any adding or subtracting there to the original function? Is there any adding or subtracting? No. So that I'm sorry, not the vertex, but the starting point will not move. The only way that point 0, 0 can move is if you're adding and subtracting, which we're not. So definitely it starts at 0, 0. Okay, then what's going to be different about it then? Well, think about it. You're going to take those old values and you're going to multiply them by what? 2. Isn't that going to make all the other points higher up? So what's that going to do? It's going to make the graph what? Rise more what? Quickly. So whatever the normal graph looks like, just make sure it rises more quickly. Maybe something like that. Does that make sense? See how I made that one rise a little bit more quickly? Because you're taking the old y values and you're doubling them by multiplying by 2. Does that make sense? Does everybody understand why the starting point does not change? The only way that starting point can change is if you're adding or subtracting with the function, right? That's what moves the starting point around, doesn't it? All right, good. So, Evelyn, what's the domain? Quick.
X is greater than or equal to 0.
Okay, good. Dominic, what's the range here?
Y is greater than 0.
Yep, or equal to, right? All right. Okay, so there it is. So you're going to have several problems on your homework tonight like that. Can you handle it? Can you handle it? Okay, now they're going to get a little bit more complicated on the next page. Okay, we're doing the same thing. Are you ready? Shh. Shh, 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 shh. All right, so shh. if you're not sure there's three things going on here, isn't there? There's an addition of 1 inside the function, there's a subtraction of 3 outside the function, and then outside the function there's a multiplication of 0.5. So there's 3 changes to the original memorized graph. If you're not sure which change to make first, let me recommend you follow PEMDAS. Okay, so the first change would be what? Inside, because inside the function is like inside parentheses, right? So the first thing you do is move everything what? 1 to the what? Yep. Shift left 1. Okay, the next thing you're going to do is what? Multiplication. What's this? What's 0.5 going to do? Multiplying by 0.5 is going to make the old y values what? Smaller. So it's going to what? It's going to what? Rise more slowly. Good. That's good. And then the third change is going to be what? The subtraction of 3 on the outside, which moves everything what? Yeah, shift down 3. Okay. Whoops, not 1, but 3. There we go. Everybody with me on that? Okay, so what would normally start at 0, 0 then is going to go what? Left 1. And when you draw the graph, it's going to rise more slowly. I'm not going to draw it yet because I still have to move everything what? Down 3. So if you move it down, left 1, down 3, do you agree that this is going to be the new starting point right here? Yes? Yes or no? Okay, and then we said it was going to rise more slowly, didn't we? Because you're multiplying the old y values by 0.5, which makes them smaller, doesn't it? Yes? So make a really, really slow rise here. Everybody got that? Okay? And by the way, now that you have the graph, you should easily be able to look at the graph, Rachel, and pick out the domain. What is it?
X is greater than or equal to -1.
Okay, good. And Hallie, what's the range here?
Y is greater than or equal to -1.
Okay, good. All right. All right, we're going to do B together. Okay, any questions on part A here before I move it over? Are we good? Okay, so again, when I say graph roughly and I give you something like this on your homework tonight, this is exactly what you're going to do. Is this very hard? No. If you look at your notes, this should be pretty easy. I mean, it gets a little harder towards the end of the hour, but right now I think you guys should agree this is pretty reasonable. Okay, let's look at this. All right, again, let's start with the inside. What does that do, guys? It moves everything or shifts everything what? Right 2. Okay. What is the minus? What happens when you multiply by a negative? You saw this with parabolas. The parabola would be a u opening upward. When you multiply by a negative, it opened what? Downward. So that what? Flips it what? Flips, yeah. How would we say that? Flips what? Vertically. Doesn't it flip vertically? Is a way to say that? It's a vertical flip. Yes or no? Yes?
Yes.
Okay. And then finally, adding 3 on the outside moves everything what? By the way, it shifted right 2. It shifts or moves everything what? What's the plus 3 on the outside do? It moves or shifts everything what? Up 3. Okay, are you ready? Okay, the graph of a square root function normally starts at 0, 0. But we're going to change that, right? Because the new graph has to be shifted 2 units to the right. So move your pen over to there. It's got to be flipped vertically, which we'll worry about in a minute. And you got to shift it what? Up 3. Yes? Okay, and so flipping vertically, instead of opening upward, it's going to what? Instead of rising from left to right, it's going to what? It's going to fall. Or go downward from left to right like that. Isn't that what it would look like if that's flipped from the normal function that we've been working with, right? Do you agree that that's flipped vertically? Because of that negative out front, instead of rising gradually from left to right, it falls gradually from left to right. Got it? Yes or no? Okay. All right, now you can look at that, Tommy, and give me the domain, please. X what?
X is greater than or equal to 2.
Okay, good. And Zach P, you can give me the range.
Y is less than or equal to 3.
Okay, good. Everybody agree the range is y less than or equal to 3? Yes, because 3 is the highest y value, and then it just goes down from there, right? All right, so that's one thing you're doing on tonight's homework. Now we're going to shift to something definitely different, okay? So, Jack, you got to pay attention. Okay. A while ago, again, Jack, you can just read this. Go ahead. Read it.
In section 6.1, we simplified radicals such as square root of 50 by looking for a perfect square factor. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. In the radicate of 50.
Okay, by the way, this is a radical, but the number inside a radical is called a what? Radicand. Okay, that's just a new vocabulary. Okay, no big deal. All right, so this is a review of what we did. Can I break square root of 50 up into 25 times 2? And why did I do that? Because 25 is a perfect square. Does that make sense? And then I can split it up according to our rules into 2 separate square roots if I'd like. And then we all know what's the square root of 25. What's the square root of 25, guys? 5. And so do you agree that basically the square root of 50 is the same as 5 times the square root of 2? Would you agree those are the same thing? Okay, this is just simplified. That's considered simplified. Okay, so you should be able to break down a radical like that on tonight's homework. And that's going to be one small piece of what we're doing today. Are you ready? All right, now this is very important. You've got to look at these 3 things. What do you notice here? All 3 of them have what? They all have a what? A radical where? In the denominator. Do you agree they all have a radical in the denominator? When that happens, technically we don't consider these simplified. They are not considered simplified because they have a radical in the denominator. It's okay to have a radical in the numerator. That's considered simplified. But when you have a radical in the denominator, it is not considered simplified. So we got to fix that every time. How do you fix that, Jack? Well, there's 2 tricks you're going to learn to fix that. Are you ready? Ben, with me? There are 2 tricks you're going to learn. What's trick number 1? Read it, Trevor. What's trick number 1? By the way, wait, let me back up. Let me back up. Jessica, you can read that.
There are techniques to eliminate radicals from the denominator. Anytime we eliminate a radical from the denominator, the process is referred to as rationalizing the denominator.
Why in the world would I call this rationalizing the denominator? Well, remember, numbers with square roots, if they don't simplify to a whole number, are irrational, right? And so by getting rid of the radical in the denominator, we're turning what was an irrational number into a rational number in the denominator, which is why we call it rationalizing the denominator. Does that make sense? Okay, so anyway. All right, so what's the first trick here, Trevor? Read it.
Fractions that contain a single term denominator with radicals such as 2 over the square root of 3 and the square root of 7 over the square root of 5. We can eliminate the radical by multiplying the numerator and the denominator by the radical we see in the denominator.
Okay, so that's trick number 1. And again, I'll do a couple examples, but you're probably not going to remember this when you go home tonight or whenever you do your homework. So guess what? You better have your notes out when you're doing your homework or you're going to be confused. You're going to have a hard time doing it. Is that clear? Okay, so anyway. All right, so here's the first problem. Why is that not simplified? Because there's a what? There's a what? Radical where? In the denominator. So how do we fix that? Well, what did I say? You what? You can multiply the what? The numerator and the denominator by what? The radical we see where? In the denominator. So, what you're going to do is you're going to take the original problem and you're going to multiply it by what? Square root of 3 over square root of 3. Now, wait a minute. Why can I do that? Aren't I changing the problem? Well, it might look different, but why is it the same value? Because square root of 3 over square root of 3 is just the same as multiplying by what? 1. And we all know when you multiply something by 1, it doesn't change its value, does it? Okay, do you see why we're allowed to do it, first of all? All right, now what do we do? This is not easy, guys. Please watch. Please watch. Put the calculators away. Are you ready? Jack, please, can you close your book? You're missing this. Okay. When I multiply fractions, you all know you can just multiply the numerators, and so there's really not a whole lot you can do it there. Just leave it as that. Okay, now here's the tricky part. When I multiply the denominators, what's the square root of 3 times the square root of 3? Everybody, what's the square root of 3 times the square root of 3? 3. Why? Why is it 3? Well, read my note. Why is square root of 3 times square root of 3 equal to 3? Well, think about it. In general, what's square root of a times the square root of a? Doesn't that turn to square root of a squared? And don't the square root and square cancel out, leaving you with just what? A. So do you agree that square root of a times square root of a is just a? All right, what's the square root of 15 times the square root of 15? 15. What's the square root of 58 times the square root of 58? 58. What's the square root of 7, Tommy, times the square root of 7? 7. Okay, you get it? And so didn't that fix my problem? There's my answer. You see how there's no longer a radical in the denominator and I fixed what I needed to fix? See how it's fixed? It's not easy, okay? All right, we're going to do a couple more of these on the next page. Any questions on what I'm doing here? Okay. All right, this one. All right, do you see a radical in the denominator? Yes, that's a problem. So how do I eliminate that square root of 5? What do I do? By the way, don't ruin the problem. Rewrite it first. What can I do to get rid of that square root of 5 in the denominator? What's the trick, Jack? D?
Times it by square root of 5.
Over square root of 5? Okay, good. So if I multiply the top and bottom by square root of 5, watch what happens. On top, you guys, do you agree that square root of 7 times square root of 5, we can just combine into the square root of 35?
Yeah.
On the bottom, what's square root of 5 times square root of 5?
Square root of 25.
Which is just 5. Everybody agree square root of 5 times square root of 5 is just 5? Agreed? Okay. By the way, can I simplify square root of 35? In other words, are there any of those perfect squares that multiply into 35 evenly? Yes or no? No. So I can't simplify that. By the way, listen guys. Can I reduce the 35 into 5? It's tempting, but can I do it? No. Why not? Why can't I reduce the 35 into 5 like I did back in elementary school? Yeah, the 35 is tied up inside of a square root. You can't touch it, can you? Do you agree there's nothing else you can do here and this is the answer? Do you agree with that? Okay, box it in. All right, now, the next one doesn't technically have a square root in the denominator. Not yet it doesn't. However, wasn't there a property that allowed me to split it up into the square root of the numerator of the square root of the denominator? Wasn't there a property like that? And what is the square root of 4, everybody? What's the square root of 4? What is it? 2. All right, so I can go to there. That's just obvious. But what's wrong? What's wrong with that? There's a what? Radical where? In the denominator. So we don't consider that simplified. So there's a way to get rid of that. And what's the trick? What's the trick to get rid of that square root in the denominator? What's the trick? Yeah, you multiply numerator and denominator by what?
3.
Not 3, but square root of 3. Very good. All right, now, when I do that, in the top, there's not a whole lot you can do. Just leave it as 2 times the square root of 3. There's not a whole lot you can do there. But in the bottom, what's the square root of 3 times square root of 3? Everybody? 3. All right, now, before I box that in, can I reduce 2/3? Does 2/3 reduce? No. I mean, if it could, that would be fine. But it doesn't reduce. And I definitely can't reduce the 3's because this one's tied up inside of our square root. So I can't reduce those 3's. I can't reduce anything. Do you agree we're done with this one? Okay. Box it in. All right. Now it's going to get a little bit trickier. Again, technically I don't have a square root in the denominator yet. However, I can rewrite it as square root of 1 over square root of 8, can't I? And everybody, what is the square root of 1? 1. Okay, so no big deal, right? I'm going to there. Everybody okay with getting there? Everybody okay with how I got there? All right, now what's the problem with this answer? It has a what? A radical in the denominator. We can't have that. We've got to fix that. And what's the trick for the 5th time now to fix it? What's the trick? Multiply numerator and denominator by what? Square root of 8. And watch what happens when I do that. On top, I just get what? 1 times square root of 8, which is just what? Square root of 8. And in the bottom, what's square root of 8 times square root of 8? What's square root of 8 times square root of 8? What's square root of 8 times the square root of 8? Which is 8. But agree square root of 8 times square root of 8 in the denominator just turns into 8? Now look, we may or may not be done. Is there anything else I can do here? Is there anything else I can do before I box that in? Yes. Yes. Watch this. I'm going to do some side work here. Are you ready? And I'll label it as side work. Okay. What else can I do here? I can do what with square root of 8? I can write it as what? Everybody. I can break that up into a perfect square times another number. What is it? Yeah, 4 and then 2. So can I write it as square root of 4 times the square root of 2? And what is the square root of 4? Everybody. 2. Tommy, please, don't put it in again. What do you get? 2 and then, yeah. So does everybody agree that square root of 8 is the same thing as 2 times the square root of 2? Does everybody agree with that? Okay, so bring it back over here. I'll give you a break after D, I promise. Okay? Okay, but stay with me because we got to finish. Now wait. Do not box that in yet until you're sure there's nothing else I can do. Now look, I cannot reduce this 2 and this 8 because that 2 is tied up inside the square root. However, as long as this 2 is multiplied, which it is, isn't it multiplied by that square root? I can go ahead and reduce the 2 8s, can't I? I can reduce that like I did back in elementary school. 2 goes in there once, 2 goes in there what? 4 times. So what's your final answer? Yeah, 1 times the square root of 2 is just square root of 2 all over what? All over what? 4. You don't need the 1, do you? No. All right, one more, then we take a break. I promise. Okay, hang in there, guys. I'm getting tired too. It's warm in here, making you tired. I understand. Jack, you okay? Lauren? Yeah, I will on the break. Heads up back there. Guys, heads up. I can't see you. Okay. All right, now watch this, guys. This one's different. The obvious thing I can do is what? Write it as what? Square root of 3 over what? Square root of 7. And now there's a problem here. What's the problem here? You got a what? Square root where? In the denominator. So how do we fix that, Jessica? Multiply top and bottom here by what?
Square root of 7.
Okay, good. Notice how she did square root of 7, not square root of 3. You're supposed to multiply the numerator and denominator by whatever radical you have in the denominator. That's the only way it's going to get rid of it. Is that clear? Okay, now, watch this. We're not done. We have several steps here, and then I'll give you a break. Do you agree that these two multiply into square root of 21? Everybody agree with that? And on the bottom, what's square root of 7 times square root of 7? Well, square root of 49, which just simplifies to 7. Okay, so everybody agree that's where I'm at? By the way, can I simplify square root of 21? Are there any perfect squares that multiply into square root of 21? No. All right, so the 21's okay. The only other thing I can do here is get a common denominator, right? Everybody agree? By multiplying the 4 by what? Not 7, but 7 over, no. 7 over what? No. You can't just multiply by 7 over 1, then you're turning into a 28. You can't do that. How about 7 over 7? Can I do that? Yeah, because that's just multiplying by 1. This is just elementary math, guys. You know how to get a common denominator. That gives you what? 28 sevenths? Everybody agree? You know you can't add or subtract with fractions until you get a common denominator. That's all I'm doing. What I'm showing you right here is elementary math. Right? 1 second. And then once you get the common denominator, you bring them together under one fraction as the 28 plus the square root of 21. And that's as far as you can go. What's your question, Adi? Okay. Can I reduce the 28 and 7 here? No. Why not? Because there's a what? Addition. You cannot reduce with an addition there. So that's it. All right, take a break. We got one more concept to learn. Get up and stretch. Turn the fan on high, please. Guys, get up and stretch. Otherwise, you're going to be more tired if you just sit there and do nothing.
Why do you want the fan up high?
Because it's so hot in here.
Why is it so hot?
I don't know.
That's
The heating and cooling system is not very, how should I say, adjustable.
So what would that mean? That would mean that if it were the end of the year right now, it would be so hot in here, and we had to turn the fan on.
You're right.
Someone check the password. Can I go get water real fast?
Real quick. Run.
Well, a lot of teachers like mornings.
Yeah.
Because you want a job here, you have to be awake.
That's right. Early.
Daylight.
That's right.
I'm sure they decide they like mornings.
All set? Okay. Good, yours? Just to a water park for a couple days with my kids. Yeah. How about you? Busy vacation. Just to a water park.
Just went to near my Walmart.
The one in Frankenmuth.
We went there
Yeah. All right, guys, break's over. Let's go back.
with your kids.
Yep.
And it was good.
It was fun. Yeah. Run.
You spent every night in your own house bed. You spent the whole break you spent each night in the same bed in your house.
No, because I went out of town. All right, have a seat for me.
And then you went in the bed there.
Yeah, there.
Instead of
Yeah.
I was in the house bed.
5-10 minutes. Yeah, 10 minutes. All right, have a seat, guys. Have a seat. Let's finish this up. Okay. All right. This page will go real quick if you just pay attention. Ready? Ready? Please. All right, watch this, guys. Drew, can you read this? And can somebody turn the fan off so I don't have to yell? Steve? I'll turn it back on in 10 minutes, I promise. Shh. Shh. All right. Go ahead. Go ahead, Drew.
The expressions in parentheses,
Don't worry about parentheses. Just
C plus square root of B and C minus square root of B are conjugates.
are called conjugates, okay? So, conjugates are some in a difference that otherwise look identical, yes? So these are conjugates, and those are conjugates. Now, this is the trick right here that we're going to use. Ready? What happens when we multiply conjugates? Well, watch what happens. When we multiply conjugates, technically we're multiplying two binomials in the form where one is in the form a plus a b, and then the other one is your a minus your b. And we saw this over and over and over in the past. If you foiled a plus b times a minus b and simplified, guess what it would always simplify to? Always. It would always simplify to what? Your a squared minus your b squared. And so that's going to be part of the trick. Are you ready? So if you ever multiply conjugates, a plus b times a minus b, the shortcut is just to turn it into what? Your a squared minus your b squared. And what is 3 squared? 9. What is square root of 7 squared? Well, the square root and the square go away, leaving you with just what? 7. And then what's 9 minus 7? 2. All right, so notice what happened there. When you multiply by conjugates, you use the fact that it turns out to be your a squared minus your b squared, and you simplify from there. Is that clear? All right, now that's just one part of the trick. So let's do a whole example, beginning to end. We'll do 2 together and we'll be done. Are you ready? Once again, if you don't have your examples out when you're doing your homework, you're probably not going to remember what I did. Got it? And you know you can't just fake your way to the homework answers because I won't give you credit for that. You're going to have to show every single step. So when I give you a problem like this, to simplify, if you don't have all these steps, then I know you didn't look at your notes. Is that clear, Adi? Can you move those out? I don't know how they get pushed under there. Move the desk out. Thank you. Okay. All right, so, Adi, are you ready? So, when you have a fraction that contains a sum or difference with a radical, such as these, there's a trick. The trick is, to eliminate the radical, you simply multiply the numerator and the denominator by the what? Conjugate of the what? Denominator. So, if I wanted to rewrite that, what would I multiply top and bottom by? I would multiply top and bottom by what? What's the conjugate of 3 plus square root of 5? Everybody, what's the conjugate of 3 plus square root of 5? What is it? 3 minus the square root of 5. So if you multiply the numerator and denominator there, are you following me? Where? All I did is look at that and I said, okay, I've got a sum or a difference in the denominator with a radical. The trick is to multiply the top and bottom of that fraction by the conjugate of the denominator. Everybody agree that 3 minus square root of 5 is the conjugate of the denominator?
So you just switch the sign?
Yep, you switch the sign and then you multiply top and bottom. Okay, now look, on top, just leave it as that times that, like that. Don't distribute yet. You can distribute later if you want, not yet. Now in the bottom, what is, isn't this in the form a plus b times a minus b? And what does that always multiply into? Always. What does a plus b times a minus b always multiply into here? Guys, come on. Isn't that a plus b times a minus b? And what does that always turn into? A squared minus b squared. So what I did there is I used the fact that a plus b times a minus b turns into your a squared minus your b squared. Are you with me or not? Come on, guys. You're not going to think it's funny when you're losing points. Okay. So, everybody watch. So when I multiply 3 plus square root of 5 times 3 minus square root of 5, that just turns into your a squared, which is 3 squared, minus your b squared, which is square root of 5 squared. Are you with me on that? And then we all know that 3 squared is what? 9. And careful, what's the square root of 5 squared, guys? What is the square root of 5 squared? It's just 5, because the square and square root go away, don't they? Are you following? And then finally, 9 minus 5 is what? 4. And then what did I do on top? I what? I distributed the 7. If I distribute the 7, don't I get this? Okay, so any questions on what I did there to get my answer? Any questions?
No.
Take a look at the whole problem. Again, on your homework tonight, if this looks like one of your homework problems, I need to see all these steps here leading up to the answer, and then I want you to check the answer if it's an odd one. You're going to have your notes out when you're doing your homework. Okay? All right, last page. Okay, everybody try part A. Go. Do it. Everybody try it. Show your steps. And yes, you can go ahead and look back at the example. Put it in your pocket. Go. Look at the example and do it. Look back if you don't know.
What is it? Conjugate of the
Yeah, no one understands.
That's 3. Yeah, I got it.
And we have like a million questions.
Exactly. So instead of complaining about it, the best thing you can do is try it. Okay? Read again what I did if you didn't get it, and then try it on the new problem. This is how you learn in math, not by giving up. Do it, guys. I told you this stuff wasn't easy, guys. You're just going to have to look at the examples and work your way through it one step at a time.
Like, on the homework, do we have to use this stuff? You do example A.
This is the only way to do it, so yes.
Yeah, I think if you do one example, we'll get it.
I did.
No. Like,
And I didn't make you write it down so you could pay attention. I did one example, real slow, and I typed it up for you. Now it's your turn to try one. Yeah, but what happened to the fraction? Oh, that's the numerator, right? You still didn't? Yeah. So far, so good. Yep.
7 over here. Why this one come back over here? 'Cause don't you?
Yeah, I distributed it. 7 times 3 is 21. 7 times square root of 5 is just 7 square root of 5. You didn't have to do that last step. Yeah, you do the opposite. That's the trick. I don't think that's right, but I might be right, actually. We'll see. When the pass comes back. Who has the pass, Brett?
For this one, can you simplify the 4 and 8?
Yeah, that's why you should have done it back here before you distribute it. So back up a step. No calculators. No calculators on this. Okay, are you ready, guys? One step at a time. By the way, please rewrite the original problem so you don't ruin it. Okay, so I have a radical in the denominator. Not only do I have a radical in the denominator, I've got a sum along with it. And so there's a different trick, right? We use the second trick. What's the second trick? You multiply top and bottom by what? The conjugate of the denominator. What's the conjugate of 5 plus square root of 2? 5 minus square root of 2. Any questions so far? Okay, now, when you multiply the numerators, right now just leave it alone. Do not distribute that 4 on top. Just leave it as 4 times, in parentheses, 5 minus square root of 2. Don't do anything on top. All right, now in the bottom, notice something. Aren't you just multiplying something in the form a plus b times a minus b right here? Aren't you? And we all know when you multiply binomials in the form a plus b times a minus b, if you went through the whole FOIL, if you went through all that, it would always simplify to your what? Your a squared minus your b squared. So instead of going through the whole FOIL method, why don't we just take the shortcut and say it's going to be your a squared minus your b squared, yes? And what is your a? What's your a? 5. What's your b? Not 2, but square root of 2. Any questions so far? Okay, again, leave the top alone. Don't do anything to it. Shh. Now on the bottom, what's 5 squared, guys? 25. And what's square root of 2 squared? Well, the square root and square go away, leaving you with just what? 2. And so that is your answer. Now, shh. You guys, if you were checking your answers in the back of the book and that wasn't the answer, then there's probably one other thing they might have done, which is what? Well, first of all, does 420 over 23 reduce? Does it?
No.
No. If it did, I would go ahead and do that, but it doesn't. So the only other thing you can do here is what? Distribute on top. So if I distribute, I get 20 minus what? 4 square root of 2, and then all over what? 23. Is that clear, guys? Okay, one more and we're done. Try it. Give it a try. You've seen 2 of them now. You should start to get the hang of it. Okay, do me a favor. Erase that last step for a second.
Erase that?
Yeah. All right, now, leave the numerator alone. Copy it. Remember, you only distribute as the very last step. Okay, what's 1 minus 3? Put it there. All right, now, before you distribute, can't you reduce 8 halves? Do that first. Right, that's the conjugate, right? The conjugate is the opposite sign, right? That's right. You got to use opposite sign to get the conjugate. That's right. That's right. That's exactly what you need to do. You need to use the conjugate, which is the opposite sign of what it started as. Yeah. Okay. Good. Keep going. Keep going. What's square root of 3 squared? Doesn't it just turn into 3? And doesn't that just turn into 1? Keep going. You doing all right here?
I got the first one already.
Okay. Okay, so when you multiply those, isn't this a minus b times a plus b, which turns into what? A squared minus b squared. Agreed?
It's already a minus.
Yeah, but you multiplied them. This is your conjugate, right? To get the conjugate, you take the opposite sign. And now when you multiply a minus b times a plus b, it turns into a squared minus b squared. All right, let's get started, finish it up, and that's it. Guys, have I convinced you by now that you need to have your notes out when you're doing your homework? You have to. You're not going to remember all this. There's no way. Not the first time you see it. There's no way you're going to remember it all. Okay, so watch. Isn't this a conjugate situation? Okay, so what do I multiply top and bottom by? What's the conjugate of that, guys? What's the conjugate of 1 plus square root of 3? 1 minus the square root of 3. Everybody agree with that? Okay, so on the top, just leave it alone. Don't distribute until the very last step. On the bottom, isn't this in the form a plus b times a minus b, which we all know always turns into what? Again, if you didn't notice, I'm using a squared, a plus b times a minus b equals a squared minus b squared. Everybody agree with that? So with that in mind, in the bottom, I end up with 1 squared minus square root of 3 squared, don't I? Okay? And then from there you just simplify. So again, leave the top alone for now. In the bottom, don't I get 1 squared, which is 1, and then square root of 3 squared is just 3, isn't it? Don't distribute yet. Don't distribute until the very last step. Okay, any questions so far? I'm not done, but I'm getting close. Any questions so far? All right, before I distribute the 8, can I reduce that 8 at all? Yeah, I can reduce the 8 with the negative 2, can I? What is that simplified to? Well, let's see. 2 goes in there 4 times. 2 goes in there once, so I get this, right? Shh. And by the way, 4 over negative 1 is just what? 4 over negative 1 is just what? What's 4 over negative 1, everybody? Negative 4. And so there's your answer. Now, if you want, you could distribute. And if you did, what would it be? Negative 4. Minus or plus? What's a minus times a minus? Plus 4 square root of 3. Yep. Yeah, you know what? I copied it wrong. Whoa. All right, I'll fix it. I'll fix it. There's a minus, there's a plus, there's a plus. There's a plus, there's a plus, there's a plus, there's a plus. Everything else is okay, isn't it? No, the no, it's okay.
It should be 1 plus 3.
No. No, because it's still a plus b times a minus b, which still turns into a squared minus b squared, regardless of the order. So that's all right. So the only difference is in the last step. I apologize, guys. The heat's getting to me. Is this right? Is that right or no? Is that okay, guys? It's okay now. Take a look at it. Yeah, I just copied the problem wrong is what I did. So does everybody agree you should have multiplied by 1 plus square root of 3 over 1 plus square root of 3? That's the conjugate of what it started as? No. Look, guys. Look. Shh. Guys, have a seat. I'm not done explaining. Have a seat. You guys, the bottom is still a plus b times a minus b, which still turns into a squared minus b squared. Doesn't it? So the denominator is okay. So the only mistake I made is I copied the problem wrong. It started out as a minus here. So you were supposed to multiply by 1 plus the square root of 3 over 1 plus the square root of 3. Sorry about that. I just copied it wrong. Sorry about that. Why didn't you guys stop me a long time ago? Is this okay now? Does everybody agree this is the right answer here? Okay? All right. Good job. You guys, follow directions. No calculator there. For these problems, follow those directions. For problem 12, follow those directions. For 15, use a calculator. And for these, just do whatever we did in the notes. Got it? Okay?